Hello. This week we're going to be working on Chapter 7, Section 7, Multiplying Polynomials. So previously we talked about adding and subtracting polynomials. We talked about the concept of adding like terms and how that's related to place value. In this example, we are going to multiply. And let me just borrow this for just a second. I'm not going to put this in the main video, but we know that like if we're going to add, for example, 24 plus 17. Actually, 17 is probably a bad example. I don't want to roll over into the next place value. So how about 24 plus 13? That'll be okay. We know that we talked about adding them vertically. 2 plus 1 is 3, so this actually means 2 of the 10s plus 1 more of the 10s gives me 3 of the 10s. And we actually have words for that. 20 plus 10 equals 30. 4 of the 1s plus 3 of the 1s gives me 7 of the 1s. So this is in the 10s position and this is in the 1s position. And that's all from last week. And the same thing happens if I do 2x squared plus 4x and 1x squared plus 3x. So we add things by place value. But what if I multiply? And let's just keep it simple, okay? So I'll do 24 again. Well, I'll use the same things. What if I multiply 24 times 13? So what ends up happening is I have 3 times 4, which is 12, and now I've got that extra 1. Where do I put that at? Most of the time when you learn to do this, you put it up there, you kind of carry the 1 is what we call it. But what that means is that 4 times 3 is 12. I've got a 2 in the 1 spot, and I've got a 1 in the 10 spot. So now I've moved over into the next place value. And if I keep working this is not 3 times 2, this is actually 3 times 20. 3 times 20 is 60, plus 1 more is 70. And the one thing that gets confusing is when I start to do the next line, I do 1 times 4. I don't put it here, I put it here. 1 times 4 is 4 right here. Why? Because this is not 1 times 4. This is 10 times 4, so I get 40. And then, of course, 10 times 20 is 200. So what I'm going to find out is that when I multiply, I actually increase my place value. I don't know if increase is the way that I'm going to mention it. Let's get rid of that for a second. So how does that apply to anything that's happening here? Well, we have to understand what this actually means, right? 5x to the second power, and these parentheses mean multiply. This is a monomial times a monomial, multiplied by 4x to the third power actually means 5 times x times x. That's the 5x squared. Times 4 times x times x times x. That's 5x to the second power times 4x to the third power. And because of something called, well, actually two somethings, they kind of go together. The associative property, which means if you're multiplying a bunch of things, you can pick any two to start with, because multiplication only takes 2 things at a time, all right? Because of the associative property, and also I guess you can kind of include the commutative property. Commutative property means that the order doesn't matter. So 3 times 7 is the same as 7 times 3. So basically what I'm saying is that the order doesn't matter here. So I'm going to put the 5 and the 4 together. 5 times 4 equals 20. And then I got a bunch of x's being multiplied. X times x times x times x times x. That's x to the 5th power. So is there a way for us to figure out how to do this without having to, this is called expanded form, without having to write it in the expanded form? First of all, I want to say this. You can always write it in expanded form. And I'll do it a couple times so you can see how this works. But is there a way to do it with a shortcut? Well, actually, yeah. We have what we call a rule for exponents. It's a property. So if I have x to a power, I'll say to the a power. And that a just means anything. Could be a 2, could be a 2, if there's a 2, could be a 3, could be a 5. Any exponent power. And if I multiply it by x to another power, and the important part is that these two things, which we call the base of the exponent, they have to be the same. So when I get here where I got x's and y's, I can't put those together. But if they are the same, then I can put them together. This tells me how many x's I'm going to have multiplied together. So if that was 7, I would have x times x times x times x times x times x times x, 7 of them. This tells me how many of these x's I have. And then when I put them all together to the same base, all I have to do is add the exponents. So like here, the 2 plus the 3, 2 plus 3 is 5. And where did that come from? Because I've got 2 x's being multiplied here, and 3 x's being multiplied here. 2 plus 3 equals 5. The hard thing about this is remembering that exponents, it's counting. You are counting the number of bases, the x or later the y, or the a, the b, the c, but you're counting the number of bases that are being multiplied by themselves. So that's where the counting part comes from it. And adding is just a shortcut for counting. Here I'm counting them. If I didn't put this in, I would just add 2 plus 3 equals 5. I'm going to write this one out. I'm going to expand it, but then I'll do it with the shortcut. So I've got negative 3 times x to the third power. So that's 1, 2, 3. X times x times x. Times y to the second power. Y times y. Now, oops, didn't mean to do that. All of this right here is expanded into negative 3 times x times x times x times y times y. And honestly, you can probably tell why we use exponents, because it's easier to write than this. Now in the next monomial, I'm still multiplying, everything's multiplying, times 4. This time I've only got 1x, and then I've got y to the fifth power, so that's y times y times y times y times y. Now I'm going to put all of the constants, I'm going to multiply those together. Negative 3 times 4 is negative 12. Now let's multiply all the x's together. I've got 1, 2, 3, 4 x's, no more. So that's x to the fourth power. Let's do the y's. 1, 2, 3, 4, 5, 6, 7. Y to the seventh power. Now you could have gone directly from here to here. Negative 3 times 4 is negative 12. 3, and here's where we show hidden stuff, plus 1 is 4. And 2 plus 5 equals 7. I'm going to expand this one out, but on the next problems we're going to do, I'm going to do it without expanding. So I've got 1/2. I'm going to write it over here on the side. 1/2 times a to the third. That's a times a times a times b. Multiply that by a to the second. That's a times a. And I've got c to the second times c times c. Times 6 times b to the second, which is b times b. So I've got a bunch of variables that are a couple of b's, and a couple of c's. Let's put them together. 1/2 times 6 is 3. How many a's do I have? I've got 1, 2, 3, 4, 5. A to the fifth power. How many b's do I have? 1, 2, 3. B to the third power. And how many c's? None here, none here. 1, 2, no more. C to the second power. Now, could I have done this without expanding it? Yes. I would have taken the 1/2. The coefficient here is just 1. So multiplying by 1 doesn't change anything, so you can ignore it for now. 1/2 times 1 times 6 equals 3. How many a's do I have? I've got 3 here, 2 here, no more over here. 3 plus 2 equals 5. How many b's do I have? I have 1 here, 2 here, 1 plus 2 equals 3. And how many c's do I have? I have only these two, c to the second power, so that's it. Okay, so I'm going to keep doing some examples here, but before I switch the paper, I just want to point out something, okay? I mentioned earlier that you can turn things around when you multiply. For example, like I said, 3 times 7 is 21 and 7 times 3 is 21. So when I have letters that represent variables, the order doesn't really matter. So for example, and I'll just make it simple, I'm not going to change this, but for example, if I had x, y, that's the same as y times x. I'll put the, I don't know, sometimes I put the dot in there just when I say multiply. Those are the same. However, so that we can all be on the, like being on the same page, so we're all talking about the same thing, usually we want alphabetical order. And there's no math reason for that. It's not math. It only exists so that, like, if you put your solution to this problem, for example, if you had said 3 times b to the 3rd power times a to the 5th power, if you put the b in front of the a, that's correct. However, if you were to compare that answer with somebody else's answer, because remember, math is about communicating, so we want to talk to each other. If you compared your answer, then they'd be like, well, wait, why'd you get something different than I did? And of course, you know, you guys being smart, you figure out that you actually have the same thing. So usually we want to put our variables in alphabetical order. For this one, our x came before our y. So try to keep that in mind. Let's do a couple more problems. So this time I'm going to go straight to the shortcut without the expansion. All right. It might be hard for me because I always usually like to talk about the expansion. I have 3 times 6. 3 times 6 is 18. I have x times x times x times x times x. 3 plus 2 is 5. So I write x to the 5th power. And that's it. There's no more to do there. And we're going to be able to do that in the next problems when we start to, these are monomials times monomials. When we multiply monomials times binomials or other polynomials, or even polynomials times polynomials, where you get lots of terms, we'll be able to do this quickly in our head. 2 times 5 is 10. R to the 2nd, there's no more r's, so I just still have r to the 2nd. T times t to the 3rd, I've got 1 here, I've got 3 here. 1 plus 3 equals 4. And the last one, let's see if we can do this without expanding it. I have 1/3 times 12 times 1. 1/3 times 12 is the same as 12 divided by 3. That equals 4. Let's go, I got x's, y's, and z's, so let's do them in alphabetical order. Let's do the x's first. I've got x to the 2nd power here, x to the 3rd power here, and no more x's. 2 plus 3 equals 5. X to the 5th power. Let's do y's. I've got my y, no y's in here, but I've got 4 of them here, y to the 4th power. So 1 plus 4 equals 5. And that are the same, but that has nothing to do with anything, okay? I did my x's and y's, here's my x's, I got some z's. So here's z to the 2nd power, z to the 5th power, 2 plus 5 equals 7. And I always draw a line through my z so it doesn't look like a 2. So I've got z to the 7th power. Alright, in the next video we're going to be multiplying monomials times polynomials. Good luck.